This section is all about using those symbols. Make sure you have them written down, just in case you forget them. In elementary school, you might have talked about how it was like the alligator eating the bigger number. We're not doing that. We're just going to use the less than or equal to, greater than or equal to parts. Okay? You need to know what those mean and be able to kind of say them out loud. Okay? Did I expect you to remember it off the top of your head perfectly? No. Do I expect you to remember it by the end of this unit? Definitely yes. Okay? This unit will not go well if you don't. Then underneath, what we're going to do is write some of the other ways that we could say these. For instance, less than or equal to is another way, or is basically the same thing as just saying, what is the string on there? At most. So if you want to have at most 15, I don't even know what I can give an example. You want to spend at most $15. There we go. That means you want to spend $50 or less. Okay? These are way more realistic to real world problems because if you take $15 into a store, you're going to be very lucky if you spend exactly $15 on the dot. You're probably going to end up spending like $14.82. Somewhere slightly less than that, but pretty much equal if we kind of round it. Okay? At least is a greater than or equal to. So when you go to rides at like World of Fun, when you're in like elementary school, they always say you have to be at least 48 inches tall to ride them, which means you have to be 48 inches tall or taller, or greater than. Okay? So at most is actually less than or equal to, and at least is actually greater than or equal to. Okay? Greater than, these are a little bit simpler. It could be something like more than, or it could say something like longer or taller. Something that has to do with being a greater value. Okay? They're a little more obvious, but realize it doesn't say anything about being equal to. Both at most and at least have something to do with being equal to that number, and then bigger or smaller. That doesn't. Just like less than, it'll be fewer. I was about to write less than again. Smaller, shorter, things like that. These are just keywords that tell you which symbol to use. There's two more for the ones in the middle. Less than is also the same thing as saying it can be this much or less. This much or more. So if you want to spend $5 or less, that's less than or equal to. Or saving $10 or more is spending $10 greater than. Hey, it's going to be pretty much just, if you understand whether it's supposed to go less than or greater than, you're going to be good to go. Hey, it's not necessarily always going to fit this table. I just wanted to give you some ideas of times when they will come up. And what we're going to do is graph them on a number line. So for this first one, let's say the temperature tomorrow will be at least 40 degrees Fahrenheit. Where did we put at least on our table? Which symbol? Don?
Yes.
Yeah. Greater than or equal to. Because at least means it's going to be warmer. Higher than 40 degrees or 40 degrees. Okay, and we put the little bar underneath because 40 degrees is okay too. Then on your number line, we're going to put a 40. And are we going to go to the left or to the right? Yeah, the right. All the way here. Because it's going greater than. Okay, put an open circle there to start with. Who remembers when we fill in that circle versus when we leave it open? When it's equal to. Is this one equal to?
No. Yeah.
Yeah. So basically just color in the circle. Right, and that's how you put them on a number line. We're going to start off with just graphing them on the front side, and then we'll get to some one-step ones on the back side. But if you don't understand the basics first, then everything else we do this unit is going to get more and more confusing for you. Right? What about the elevation is at most 4,039? Which direction are we going to go here? You can look back at your table if you want to. Yeah. Left. At most means that's the highest point, and the only place we go from there is down. Or left thing. Okay? So sometimes, like on the first one, we wrote our inequality first. This one, I drew our graph first. It doesn't matter which one you start with. Should I fill in this circle?
Yes.
Yes, because at most means it can actually do that number too. Okay, I'm going to use E for elevation. We're going less than or equal to our number this time. Okay, again, that's when you can just look up on your table if you need a place to get started. Not all of them are going to match up that nicely though. And then it says Angela has less than $20. So we're going to start at 20 and go to the left for less than. Do I fill in my circle? No, she does not have $20. It just says she has less than. I'm going to use A for Angela. Less than has the pointy end on the left. Greater than has it on the right. Okay. And then this last section we're going to do on the front, and we're going to pause after the front side. Anytime we have notes that are going to take me longer than like 10 minutes, we'll do the front side, try some of the assignment, and come back. This part's new. You've probably never seen this part before. I'm not saying it's impossible, but I don't think you've seen this part before. It's called interval notation. Inequalities don't have specific answers. They have intervals. When you solve an equation, you get answers like x equals 2, x equals negative 2. Sometimes x equals 2 and negative 2. But for these, like this first one, the temperature could be 41, 42, 43, 44, 45, 46, 47, 48, 49, 50. That's only the first 10. It keeps going on forever. So we have a whole interval of answers. And that's how we're going to write our answers instead of x equals 2 and negative 2. Something like that. Okay? And something you need to know about intervals is they always go left to right. Just the same way you're reading this sentence right now. The way we read in English is left to right. Yes, there are other countries that read right to left, but that's not English. We're not going to do that. Okay? And basically what you're going to do is you're going to say, here's the left side of my graph. This is where it starts. Then you're going to put a comma, and you're going to say, this is how far to the right my graph goes. Okay, so for example, if your graph went from 2 to 5, you would say 2, 5. And that would include anything in between, decimals, fractions, everything between 2 and 5. Okay, then on the ends, you're going to put parentheses or a bracket. You're going to use a parentheses if it has an open circle. So the open circle part you guys already know. We just talked about it, you guys all were on track with that. Then we're going to use a bracket, which is kind of like a square parentheses. Only if it has a closed circle. Okay? And sometimes, instead of a number, our line is going to go on forever. Like this one. Going to the left, this one goes forever. We call that infinity. If it's on the left, we're going to call it negative infinity. It's kind of like a sideways 8. I'm going to draw another one of mine over here a little bit bigger, but you can always turn your paper and draw an 8 if you want. Okay, here's how I do mine. I start in the middle, and I do a loop to the left and a loop to the right. And they both end in the middle. Okay, this is infinity because if you kept doing that, I could draw this forever and never stop. It just start getting really big because I'm not exactly drawing in the same exact spot every time. Okay? So that means negative forever. And it goes negative forever on the left. On the right side, it just goes to infinity or positive infinity. Because numbers on the right side of the number line are positive. Numbers on the left side are negative. Alright, this one makes a lot more sense if we just try it. So I'm going to go ahead and scroll down to our first one. But those notes are always there if you need to go back and look at it. The first inequality is x is less than negative 1. I already know that you guys know this is supposed to be an open circle, a negative 1, and it's less than, so we're going to go to the left. That part should be really easy today. We do need to practice it though, just to make sure we remember how to do it before we get to the hard stuff. Then, for interval notation, we're going to write left, comma, right. And look at our graph and see how far to the left it goes, how far to the right it goes. As I try and find out how far to the left my graph goes, I get this arrow, which means it's all the way over here forever. Right? This side is negative infinity. This side is infinity. So my left side, because of the arrow, is at negative infinity. Comma. To the right, it keeps going until I get to negative 1. Here. And then because it's an open circles use parentheses. Like that. You'll put the whole thing in either a parentheses or a bracket. And they don't have to be the same on both sides. And I'll show you what that looks like on the next one. Okay, that is basically saying that my graph goes from negative infinity to negative 1, which is the same thing we can see on the actual number line. Okay, it's doing the exact same thing. Okay, next one, we're going to go with the inequality first. Always start your inequality with x and the number. Because now you've got half of it. You just have to decide, is it going to the left or to the right? Right. Is that greater than or less than? Which one goes to the right? Tell me you know. Which one goes to the right? Greater than or less than? Yeah, greater than. Or equal to, because we have a closed circle. I'll leave that equals to, but I won't leave it. So if I try and fix it, it'll just make it worse. Interval notation. We're going to go left to right. On the left, my graph stops at 3. It doesn't go all the way over here to infinity this time. But then to the right, it goes all the way out to infinity. The infinity only has a negative if it's going to the left forever. This one's going to the right forever. This one is a closed circle, so it hits a bracket. But here's the tricky part that I couldn't explain until we got to this example. Infinities always get a parenthesis, like this. Only the part that actually has the closed circle gets the bracket. I know that a lot of us are going to want to match them, but we don't put a bracket around an infinity because the brackets mean that you can equal that number. We can equal 3 because there's a solid circle there. But infinity is not something that we can actually equal, so infinities will always have a parentheses around them. You never have to question what they have, they always have a parentheses. Alright, and then our very last one is going from negative infinity to 2. So that means we have an arrow on the left side all the way until we get to 2. And then because it's brackets, I need to fill this in. Brackets always go with a closed circle. And that's how you take interval notation back to the graph. And now we can take the graph to inequality notation. We've got x and 2. I'm going to the left, which is less than. Remember, they both start with an L. And I can be equal to because it's closed. Okay, so yeah, if you can find the one on your homework that looks like this, it's the last section on the right, top right. It says -5 is less than x, and then we're gonna put it on a number line. But I made it kind of confusing because it's in the wrong order. If we were to put x first, like we normally see, and then -5 on the other side, something kind of weird happens with the symbol. Which part of the symbol is facing the x right now? The open part or the pointy part? The open. So we still have to make sure that the open part is facing the x. Or if you just want it as the alligator is eating the x, the alligator still needs to be eating the x. Which means that we have to go this way. If you put it the other way, the order of the problem just got you. Okay, and then it says is -7 a solution? Well, you just plug in -7 for x. Is -7 greater than -5? No, it's less than. So you're going to circle no. All you have to do is go look and see if that is actually the answer. Also, -7 would be right here on my number line. It's not part of the shaded area. So it tells you that it should not be a solution. Okay. And I'm going to do just a couple examples from the back side of the notes in about 3 minutes. Okay. I'm going to write my work up here. You guys don't have to write anything but the last line. If I take -4 and I plug it in, -4 plus 8 is 4. We just have to see, is 4 less than -3? No, it's greater than. Then this one is the same thing, but the symbol is going the other way. Is 4 greater than -3? Yes. Then these two are the same thing, where it's -4 plus 1, which is 3. And same thing over here. -3 is not less than -3. But -3 is less than or equal to -3. So notice how it has to have the little bar underneath if you want them to be the exact same. Otherwise, you have to say no. Fine, get back to your sequence. Get back to your sequence. And we got another thing to talk about today. It's not necessarily hard, but I want to make sure we're all on the same track. On the back side of your assignment, the main difference is you have to get x by itself. The exact same way we solve equations, guys. Exact. So, but now instead of calling them properties of equality, they're calling them properties of inequality because they're inequalities. So, for example, in this first one, you would just add 3 to the other side. What's 5 plus 3? 8. Awesome. X is greater than or equal to 8. So we're going to put 8 on our number line and draw an arrow going to the right. And I'll give you guys a second to do that. Subtraction, same idea. You're going to subtract 4 from the other side. -3 minus 4 is -7. But be very careful, guys, because before we just had equal signs. You don't have to worry about it. But now you have to pay attention to what was in the middle. This needs to stay here in between. And now x is less than -7. So we're going to have an open circle going to the left. Because left is less than. The less than is left. So we'll start with an L. Hey, here's where things get tricky. Notice how I separated it between multiplication by a positive number and multiplication by a negative number. Does anybody remember the rule about multiplying by a negative? You?
Always negative?
Kind of. Except for, what is the only time we multiply and it's not going to be a negative answer?
So it's zero?
They're both negative, yeah. So it is possible for it to be positive still. Here is the special rule. If you multiply or divide by a negative, let me do this. And I'm going to move out of the way so you guys can see it. If you multiply or divide by a negative number, you have to flip the symbol. Less than to greater than, or less than or equal to greater than or equal to. Okay, that has to happen. Now there's a difference between multiplying by a positive and multiplying by a negative. Positives you don't have to worry about it. Negatives you just have to go the other direction pretty much. This does get to be a little bit tricky though, because if you look at the next two examples, there is a negative involved, but the number that I need to multiply by is 3. That's not negative. So I'm fine. I don't have to switch them. Then these cross out, and you have x is less than negative 4 times 3, which is negative 12. We were multiplying by 3, not negative 3. There was a negative 4 involved, but it was not the number that was being multiplied on both sides. This is where knowing what stuff you're doing versus what's already there is really important. Okay, some of us don't always think that through all the way. Okay, and we're going to go to negative 12, open circle to the left. I changed the problem just a little bit down below. Now I do have to multiply by negative 3. And that means that I flip it. Okay, so instead of less than, now it's greater than. Notice how the 12 also changed signs. That's why you have to flip it, because we changed the sign of the negative 4 by multiplying it by negative 3. And whenever we change the sign like that, the symbol in between has to flip too. So then from 12, I'm going to go open circle still, but to the right this time. All right, 1 minute left. The same thing happens over there with division. We're dividing by 5 on both sides. Negative 15 divided by 5 is negative 3. The number I'm dividing by is 5, so I don't have to flip it. And it can still go to the right like it's supposed to. But down here, I'm dividing by negative 5. So I have to switch it to less than or equal to. Okay. Here is what I want you guys to do. Try and get the front and the first row of the backside done. So backside is going to ask you to list 3 solutions. That just means tell me 3 numbers that would be in the shaded area. So for example, this first one, it could be 8, 9, and 10. But it couldn't be 7 or 6 because that's the wrong direction. Okay, so just 3 numbers that are in the shaded area. Just so that you know there are multiple solutions here. There is a problem missing on the second row of the backside. Just get the front row and the first 3 on the backside done for today.